How do you build a tunnel? Beneath open water, 60 meters below the surface. Directly above, one of Earth's most active fault systems. Most people would say, you don't. And that's exactly why. The engineers had to do everything differently. $4.5 billion. 9 years of construction, the deepest immersed tunnel ever built, connecting Europe and Asia. But before they could lower the very first tunnel section, they first had to prepare the Bosphorus itself. But first, the engineers had to prepare the seabed, because this is where an 18,000-ton tunnel section would eventually rest. The Bosphorus didn't make it easy. Its currents flow in 2 directions at the same time. Crews could only work during short windows of calm water. So dredgers cut a trench into the seabed. Meter by meter, until everything was ready. Only then could construction of the tunnel begin, not underwater, but inside giant dry docks. One section at a time, 135 meters long, 18,000 tons. Longer than a football field, too large to transport by road. Each section contains 2 railway tubes. A steel membrane keeps the water out. Then a second protective layer is added. Built to last at least 100 years. Temporary bulkheads seal both ends. That's what allows each section to float later. But the most important component barely stands out. A giant rubber gasket, installed with millimeter precision. Right now, it doesn't do anything, but very soon, it will seal the entire tunnel. "11 massive tunnel sections. Finished, ready for transport. But transport was never the biggest challenge. Assembly was. How do you connect 18,000 tons? 60 meters underwater, with millimeter precision, to the next tunnel section? One by one. Each tunnel section leaves the dry dock. Not by crane, it's simply too heavy. Instead, it floats. The dry dock is flooded. The ballast tanks are emptied. Slowly, 18,000 tons begin to float. Now the tugboats take over. 40 kilometers to the Bosphorus. But the currents control the schedule. Crews can only work during short windows, when the water is calm enough. At the Bosphorus, the real challenge begins. Installing the tunnel. There is no second chance. The ballast tanks are flooded again. Slowly, the tunnel section begins to sink. Centimeter by centimeter, every movement is monitored. GPS, ultrasonic sensors, laser guidance, every centimeter matters. Because even the smallest mistake could keep the tunnel sections from sealing properly. Beneath the tunnel section, a perfectly leveled gravel foundation is already waiting. Now comes the final alignment. Hydraulic jacks make the last corrections. Millimeter by millimeter. Only a few centimeters remain. Then, first contact. But the tunnel sections still aren't connected. Hydraulic jacks slowly pull the new section toward the previous one. The massive Gina rubber seal touches its matching surface for the first time. There is still water trapped between the two sections. That water is pumped out, and then the sea takes over. The enormous water pressure of the Bosphorus forces both tunnel sections together, compressing the Gina seal, creating a watertight connection. But the engineers still aren't finished. A second seal. The Omega gasket is installed from inside the tunnel, providing an extra layer of protection. Then grout is pumped beneath the tunnel section, filling even the smallest remaining voids. Only now does the tunnel section become part of the tunnel. One section, complete. 10 more to go, 11 times. The same precision, the same challenge. The installation was complete, but the tunnel wasn't. Before the first train could pass through it, one final test remained. Could it survive? A major earthquake? 10 tunnel sections are already in place now. Only one remains, the last one. For the final time, centimeter by centimeter, until it reaches the previous section. Now the hydraulic jacks take over, millimeter by millimeter. They pull both sections together. The Gina gasket makes contact, but there's still water between the two sections. It has to be pumped out now. The Bosphorus takes over. The pressure of the Bosphorus forces both sections together. The Gina gasket is compressed from inside the tunnel. Engineers install the Omega gasket one final time. Grout is injected beneath the tunnel section, filling even the smallest remaining voids. Now come the pressure tests. Every seal every joint, every millimeter. Only when every measurement checks out can the massive steel bulkheads be removed. For the first time, the entire tunnel is open from end to end. 11 tunnel sections. 11 perfect connections, directly above an active fault line. That's why. Every connection was designed to flex, absorbing movement without losing its seal. Only now is the installation complete. Europe and Asia connected. Not by a bridge, but beneath the Bosphorus, an 18,000-ton tunnel section begins its descent. In the end, the greatest challenge wasn't the water, or the depth, or even the earthquake zone. It was making 11 separate structures behave as if they had always been one.